Hello and welcome class to our lecture about eggs. So we're going to talk about what an egg is, how it is formed, how they have different shapes, and then we will also talk about some of their nutritional value and what their constructs are. So let's jump right into it. An egg is a cell. You can say that it is the first cell you ever ate. So obviously, most of the time when we're discussing eggs, we're talking about chicken eggs. So eggs that come from domestically produced chickens. And in this case, it's the cell that they germinate to create baby chickens. It creates all the nutrients necessary to form a complete organism. And bird eggs have been traced to over 200 million years ago. So it's been a food source for humans for a very long time. Now, in sexual reproduction, you do need DNA from a sperm cell to develop into a complete organism. So if there is no rooster present or a male chicken, the egg will not be fully fertilized and can't germinate. Though the chicken will continue to lay about an egg every day. Depending on what breed of chicken we're talking about and their cadence, some lay more and some lay less. Also, their source of food and the time of year will also affect how many and how frequently they are laying eggs. A complete egg takes about 10 weeks to develop. It begins as a pin-sized white disc, and germ cells accumulate lipids, fats, and proteins which form the yolk and add up to 21 days worth of provisions for the chick to feed and grow with. And these nutrients are produced by the hen's liver, so the diet of the hen determines the color of the yolk. So here in this picture, you can see the dark orange color, which comes from a pasture-raised egg. So this dark orange color comes because a chicken was out in the wild foraging. They had a lot of protein. Chickens are actually omnivores. They eat bugs, maggots, grubs, as well as greenery. So the more diverse that their diet is, the darker and more rich that their yolk is going to be. Here in the middle, this light yellow yolk is coming from a probably commercially produced chicken. One that may be fed a vegetarian feed. They don't have a lot of protein. They don't have a lot of fat in their diet. And it's usually a less healthful yolk. And the final one over here, which is a lighter orange. This may also be a pasture-raised chicken. The darker orange may come from a chicken which has been additionally fortified. So what they do is they'll add growers will add marigold or red bell peppers to their diet, which results in a darker orange yolk without as much nutritional value. But obviously a wild foraging chicken, which we call pasture raised, meaning that they are permitted to go outdoors and free range, has a better egg quality. A lot of the marketing that you see around chicken eggs in the store don't have a lot of specific guidance. So a chicken that is free ranging has access to the outside, and that doesn't mean that they ever lived outside of their coop. Chickens are happy in their coop and they like to stay inside. So unless they're guided outside and moved into an outdoor environment, generally they will stay within their hen house. So 2 to 3 months later from the germination of the seed, a white primordial form of the yolk develops inside a thin surrounding membrane. And the ovary releases that completed yolk at that point. So the yolk is fully formed and the rest of the egg, the white, is completed in the next 25 hours. And that's why chickens lay about 1 egg a day. So over that 25 hours, it travels through the chicken's body and the white is added around the yolk. Now, there's a thin membrane, which is around the yolk. There's alternating layers of albumin, and albumin is the egg white. So when we're talking about egg whites, we're talking specifically about albumin. These are high in protein and water. Not a lot of fat or other minerals there. And there's 4 different layers of thin versus thick albumin around the yolk. So if you take a look at this picture right here, you can actually see the thin albumin around the thicker albumin, which is supporting 2-3 more layers of albumin within there. And the strength of those proteins depends again on the diet of the hen. So if the bird that laid the egg has a wild forage diet rich in proteins and other nutrients, it's going to have a very thick protein albumin, and it will be harder to pop. It will sit up a lot higher. You'll be able to see it. And also the freshness of the egg will determine the thickness of the albumin, because it will lose moisture over time. Okay, so now we know the albumin and the yolk. Attached to the last membrane on the yolk is the chalaza. It's spelled chalazae, it's pronounced chalaza. And this is a thick rope of albumin protein that anchors the yolk to the shell. As the egg ages, the chalaza also ages and it loses some of its strength, so it can begin to dip. And this is why if you are hard boiling an egg and you see the yolk has sunk to one side of the egg, usually the bottom where it was laying in the pot, that's because the chalaza has actually slackened and the yolk has dropped to the bottom. So the test of a good fresh egg is that when you hard boil it, you're gonna find that yolk right in the middle with a very prominent, strong chalaza. So the egg shell is made of calcium carbonate, and this is arranged into crystals by the proteins. It is impermeable, so the embryos are protected from even the driest habitat and microbes. And what happens is around those crystal shells, there is actually a substance that clogs the pores. So the shell is porous, and those pores are clogged with a proteinaceous cuticle plug that stops the water loss, and it keeps the moisture inside the shell. It also keeps bacteria and germs from getting into the egg. But once you wash your egg and remove that plug and clean it off, now all of the pores are open for bacteria and germs to get inside the egg. So farm-raised eggs, or eggs which are produced on a homestead, I have one, and when we collect our eggs, we don't wash them until we're ready to use them. And this way they stay fresher longer, and also they don't absorb any bacteria through those pores, which become then open. So after this 25 hours of the yolk being released from the ovary and traveling through the duct, the white albumin gets built up in 4 different layers, alternating thick and thin, and then the shell is created around the entire egg. It is expelled from the chicken through what we call their vent when they lay an egg. Now, the color of eggs, let me ask you a question, and I will mark this correct whether you answer correctly or not, but is a brown egg more nutritious than a white egg? Or have you heard that before? What have you heard about brown eggs versus white eggs? Well, it's a common marketing myth that brown eggs are more nutritious than white eggs, when in actuality, they have the same nutritional value. So the color of the shell of the egg is dependent on the breed of the chicken. So the same way that our bodies have different melanin levels depending on where we grew up ancestrally or where our people may have come from, different chickens lay different colored eggs. And as they crossbreed, their colors can change, and you can end up with different mottled eggs. You can end up with a dark green or a light brown, depending on where the chicken crossbred, and the eggshell will change. There are blue eggers. Just a fun fact, there are only 3 chickens in the world that lay blue eggs. It is one of the rarest colors in nature and also in chickens. So they're prized for their beauty. And that's about chicken eggs. Now, let's take a look at this diagram right here. I want you to see this image. This is the complete chicken egg. You should be able to label all of these parts should you get a question where I say, What are they? So we want to be able to identify the yolk right here in the middle. We want the albumin around it, the chalaza anchoring both ends, and the shell. There is also an air cell, which allows the first gasp of air as the chicken is born. And as they are consuming the albumin for their nutritional value as they're developing, that air cell will continue to grow. That's another way to tell the freshness of an egg, because as the water evaporates from the albumin, the air cell will grow. So if you drop an egg into a glass of water and it floats, it's because more air has been deposited into that air cell and it becomes more buoyant. If an egg drops to the bottom, it's safe to eat because it's a fresher egg. So if you're ever unsure of how old your eggs are, that's one way to test them. Now let's get into the specifics about the different parts of the egg. So the yolk accounts for a little more than a third of the shell's weight, but it has 3/4 of the calories and almost all of the iron, thiamine, and vitamin A. So almost all the nutritional value actually comes from the yolk. It has an intricate structure of these spheres and subspheres. And I love this photo because you can really see the different layers within those subspheres. Now, inside the subspheres, there's water, there's phosphorus-rich proteins. They bind iron and they act as a good emulsifier. We're going to talk about what emulsification is in just a minute. And these are aggregates of lipids and other molecules in some of the subspheres. And these are low-density lipids, LDLs, which can affect our blood cholesterol, but they have a great capacity for emulsifying mixtures of fat and water, which we'll get to in just a second. Now, as we add salt, the salt will actually deflect the subspheres and allow them to become clearer and thicker. So as we cook the yolk, it hardens the subspheres into drier particles, and the particles can present a crumbly texture. So if you've ever overcooked a hard-boiled egg or overcooked an egg and it's gotten very dry and crumbly in the yolk, what happened is the proteins have fully curdled and you've also expelled all the water and the moisture, and you're really seeing those little subsphere granules, and it almost becomes like sandy and gritty. And that's those subspheres within the yolk. Now the white forms 2/3 of the egg's total weight, but 90% of its composition is actually water. The rest is proteins, minerals, lipid-like material, vitamins, and glucose, but really it's mostly proteins and waters. And there's 12 different proteins that compose the egg white, but the most common is going to be albumin. And most of the egg in general is composed of protein. In the white, these proteins accumulate a negative electrical charge and they repel each other. And in the yolk, some will repel each other and some are bound up in fat protein packages. But remember, if it carries a charge, it means that it would what? It is what? If it carries a charge. What happens when it reaches the universal solvent? Right. If it meets with water, it's going to be dissolved into water because it carries a charge. It's a polar molecule. Now, as these proteins come together and we apply heat, an egg is a perfect example of what happens to proteins. So as we apply heat to the proteins, they begin to, what's the first thing that they do? Denature. They open up, they denature and unfold. Once they've unfolded, they're going to coagulate. And if we continue to cook them, what ends up happening when they fold really tightly on themselves, all water and all lipids are expelled, they curdle. Excellent. And we never want our eggs to curdle. That's where you get those really rubbery egg whites or really dry, gritty egg yolks. That's not something we're looking for. So we want to make sure that we're cooking them just to coagulation, but not to curdling. And you'll know that they're beginning to coagulate when you see the color shift from a clear to opaque color. You're literally watching the proteins unfurl, open up, and you're seeing them kind of create a solid web. Much like if you had a set of blinds and you take the blinds from like this and you turn the blinds up and you create a solid state. The actual amount of material hasn't changed, but its presentation has. And that's that egg white as it turns from clear to white, the albumin. All right, let's stop here and do a quick recap about egg whites and egg yolks. So egg whites, where is the nutritional value in the egg whites? Egg whites are mostly composed of what type of molecule? What type of molecule compose the egg whites? Right, albumin and water. So egg whites are mostly albumin, a protein, and water, whereas egg yolks contain... Correct. All the fat, water, micronutrients, vitamins, iron, those are all found in the egg yolk. So the egg yolk, while it is smaller in its total weight, it accounts for 3/4 of the calories of the total egg. And an egg is made over how many hours? How many hours from when the egg is released from the ovary of the chicken to when it is expelled? About how many hours? 25 hours. So one day, 24 to 25 hours, one day it takes to lay an egg. All right, let's keep moving on. Now let's talk about proteins and coagulation. So we know that coagulation occurs when we apply heat to proteins, but at what specific temperature? Egg whites and egg yolks are going to coagulate at different temperatures because of their properties. Because egg whites are mostly protein and water, they're going to coagulate at a lower temperature than egg yolks. This is how you can achieve something like a sunny side up egg or an over easy egg, where the egg white is fully set and the yolk is not fully coagulated yet. It has denatured, so it's not raw, but it's not fully coagulated. Really cool. The next slide, you can see here different coagulation temperatures for eggs and at what temperature. This is in Fahrenheit as well. They're going to set and fully firm. So if we're talking about a 6-minute egg versus a 12-minute egg, you're going to see a very different structure within the yolks and the whites of those different eggs. Now, some of the methods that affect denaturing are if an acid or a salt is added. These will force the proteins to move closer together, and coagulation will happen at a lower temperature. If you dilute the eggs using other liquid, it will raise the temperature of coagulation. So adding water or adding other liquids to the eggs will raise the temperature of coagulation. Something like if you're making custard, what you're doing is forcing the eggs to gently just reach coagulation without curdling in any way, shape, or form. And at that point, you're adding milk, which is going to intersperse between the proteins and cause coagulation to happen at a higher temperature so you can fully set them. And they create like a web suspending the milk, and that gives you the body of the custard. Now, when you do this, the coagulation temperature will raise to around 83 degrees Celsius instead of 70. And it's a very fragile network like we talked about. So if you continue to apply heat or you overcook, you're going to curdle your eggs, in which case it's going to be almost like seeing floating scrambled eggs in a watery mass. And it's going to be sweet, and it's not really something that anyone looks forward to. Now, there are some times that we do want to curdle our proteins, and that's when creating milk. To create cheese, we do curdle the proteins in the milk to form cheese curds, but that's not something we're talking about with the eggs. So with custards, we do what's called tempering, and this is where you add a small amount of the very hot liquid to the very cold egg yolks, and this allows the temperature to gradually raise. Quick, sharp temperature changes are going to force coagulation to happen sooner. So by gradually increasing the temperature and allowing those proteins to fully denature before they coagulate and curdle, we're able to allow them to set at a much lower temperature. Now, there are certain things about eggs that can have an off-putting flavor or a delicious flavor. So the egg yolk has a higher content of lipids in the fats that are in there. Again, we talked about that LDL cholesterol being in there. It has a very sweet, buttery quality and gives it a lot of flavor. They also have iron in there. And if they continue to cook, the sulfur-containing proteins react and iron sulfide is formed, which gives us that really funky sulfuric flavor of the eggs. If you've ever seen like that green ring around the eggs, the iron sulfide has formed and gives us that really strong off-putting smell. There are actually 100 to 200 compounds in the aroma of a cooked eggs, and the longer the sulfur atom reacts, the stronger that sulfur flavor can be in the final product. And not really something desirable. All right. Now, I know I'm on the older end of the spectrum, but I am still glad that in all the years I've been teaching this class, my celebrity example still holds up. So, you know who Beyonce is, right? She's a pop star. Yep. And she wears these really lavish outfits for her performances. So here in this image, she's got on this glittery one-piece outfit. She's got the full makeup. She is ready to go on stage right now. And she is on 49th and 10th doing some shopping. So Beyonce's over there shopping. She's whatever, needs to pick up a new pair of shoes. And she has her show in Times Square. Now there's a parade on 8th Avenue. Beyonce has to get from 49th and 10th to Times Square. She can't fly. The motorcade can't get there because the parade's in the way. There's no subway that runs. She can't magically teleport. There's no magical way for her to get around. How does Beyonce get from 49th and 10th into Times Square? She has to walk. That's the only way. She's got to walk. And she's got to cross through the parade route. Now, this is Beyonce, right? If you know who she is, and I know who she is, and she's been my example in this class for 10 years, a lot of people know who she is, so she can't just walk through Times Square, right? She's not just going to walk down 49th in her full outfit. You know, everyone knows who she is. How the heck is Beyonce going to get from 49th and 10th into Times Square? Bodyguards. Bodyguards. Now, I want you to think of Beyonce traveling from 49th and 10th into Times Square and how she's physically going to do that. So the bodyguards will actually surround her and allow her to move through the crowd, slowly move through the crowd that she otherwise would not be able to pass through. So what does this have to do with chemistry of cooking? Thank you, Chrissy. Whatever. We're talking about emulsification. So emulsification is where we have a fat droplet, which according to the Van der Waals effect and its non-polarity, cannot mix with water. This fat droplet is a celebrity. It's a mega celebrity. And it can't be held in a group of us normal plebes. So what do we need? We need bodyguards. We need someone that can both mix with the celebrity and the normal people and allow them to move through this solution. So when we create an emulsification, we're talking about a stable, homogeneous mixture between polar and non-polar substances. And the way that we do that is using an emulsifier. And this emulsifier has a phosphorus head usually, and then it has a lipid tail. So it's both polar and non-polar. And this means that it can straddle into both of those worlds. And it surrounds the fat droplet and it suspends it in the aqueous solution. And this is what creates thickness in a lot of our foods. Now we're talking about it in the egg lecture because the most common emulsifier to use is egg yolk. It's only found in the egg yolk. Both lecithin and phosphinin in the egg yolks are emulsifiers. And what they do is these emulsifiers that have the unique property of being both polar and non-polar straddle between the polar and the non-polar world. So they hold that fat droplet suspended in an aqueous solution. Now, they can be formed in a hot or a cold environment. You probably have met an emulsifier before. If you've ever put mayonnaise on your sandwich or went out for brunch and had eggs Benedict with hollandaise sauce, those are emulsified sauces. Now, the key here is that it is a stable, homogeneous mixture. So what does it mean when I say that something is stable and homogeneous? Right, it's not going to separate over time. So if I'm talking about a salad dressing, which has oil and vinegar, and I just shake it up, it may stay mixed for a short period of time, but it's not stable. If I leave it alone, eventually the Van der Waals effect will take place, the lower density oil will rise to the top, and the vinegar water-based solution will be on the bottom, and they're going to separate. Now, if I add an emulsifier to that, like egg yolks or mustard, which is another great emulsifier, they're actually going to bind together and create a stable, meaning it does not change over time. A homogeneous, meaning of one texture, of one kind, sauce, which then is nice and thick. So if you'd like a great, that's why a lot of Dijon is used, or mustard is used in dressings, because they get to be nice and thick. So you can do a hot emulsion or a cold emulsion. Obviously, mayonnaise is an example of a cold emulsion, but a hollandaise sauce is an example of a hot emulsion. And you'll see this when you do your egg lab. So this is what we've learned so far about eggs. Now I think it's time to do a recap. Are you ready for all the Playposit questions? Remember, I grade on Mondays, so I'm going to update grades the Monday after it's due. So after your Playposits are due, I will update your grades on Blackboard. So don't be disappointed if you see that you got a low score when you're checking your Playposit, because what's actually happening is I'm reading every response that you write and I'm responding. My goal is to make sure that you learn in this class, and even though we're not together in person or even holding Zooms in real time, I want to make sure that you're getting the materials and that you're understanding them. And that's the goal of this course. This part of the egg contains most of the nutrients of the egg, even though it doesn't contain all of the weight. It is composed of both lipids, proteins, water, and vitamins. The yolk. That's right. This part of the egg anchors the yolk to the shell and is a tightly wound strand. What's that called? This part of the egg is porous if left washed, but unwashed, it protects the egg from jostling and outside interference like bacteria and germs. The shell. Excellent. So now we know the different parts of the egg. Which part of the egg is responsible for emulsification? And can you define emulsification? What is emulsification? And what is required in order to create an emulsification? So make sure that you tell me what is an emulsification and what is required in order to create it. Right, so emulsification is a stable, homogeneous mixture between polar and non-polar substances. We must have a polar substance and a non-polar substance, and we must have an emulsifier present. Excellent. If you have any questions, now's your time to ask them, or if there's anything you're unsure of, now is the time to put it in these comments. Great. I hope you have a wonderful week, and I'll see you in your next video. Take care.